Hi, my name is Kyoung-Soo Lee. I'm an associate professor and also one of the handful of astronomers working at Purdue Physics and Astronomy. My main research area is formation and evolution of galaxies and also clusters of galaxies in distant universe. So it's one of the areas that James Webb Space Telescope is tailor-made for. So naturally, I'm very excited about the launch of James Webb this month. So ever since I was a little girl, I have always been fascinated by the universe. I had so many questions from where we came from to why stars and galaxies look the way that they do. When I was a little older, I read about what astronomers know about the universe, and then that made me curious about how they know. So one thing led to another. Here I am, a professional astronomer. Tell you a little bit about my research. I'm interested in understanding how galaxies are born and grow bigger by forming more and more stars, a process known as star formation, but also by merging into one another. And then ultimately, they get quiescent, meaning they stop forming stars altogether and just grow old. I'm interested in learning how this whole process of galaxy formation and evolution is linked to the cosmic structures that are mostly made of dark matter. So I'm particularly interested in how galaxies form in the most crowded environment known as galaxy clusters. So think of New York City, and you're walking on the street, and there will be so many people on the street that you frequently walk past or sometimes even run into some of them. So galaxy clusters provide an environment just like that. And they are the largest cosmic structures that you see in the universe. Their total mass can be as large as hundreds of trillions of sun. So they're really big. So in my research group, we're using ground-based telescopes to find these cosmic structures that will evolve into galaxy clusters. And because light we observe has a finite speed, and we're looking sufficiently far back in the distant universe, that we're effectively looking in the past and when the structures and the galaxies in them are only just beginning to form. So instead of galaxy clusters, I'm going to call them infant galaxy clusters. A more professional term would be protoclusters. So while we will be finding hundreds of these infant galaxy clusters using ground-based telescopes, but we need James Webb to study these galaxies in much further detail. For example, to understand how these galaxies really look like, we need high-resolution observations made outside of the Earth atmosphere, which makes everything blurry. So that's why Hubble is so good at making crisp images, and James Webb will do the same, only that it will be much better, particularly at infrared wavelength than Hubble. James Webb can also do spectroscopy on these galaxies that we find, which can be used to determine how long ago they formed and how many stars they already have, and so on. So all in all, James Webb will truly revolutionize our understanding of how galaxies form and grow and how they change from these baby galaxies when the universe was very young to the types of galaxies that we see in the present day universe by allowing us to look at these galaxies in the level of detail that has not been possible. So I am involved in a James Webb program that will study how average galaxies form and evolve. And once it successfully launches, which I hope it will, I hope to make use of James Webb to study my favorite infant galaxy clusters and their members in the future.